In this episode of Shaping the Future, I am speaking with Director of the Centre for Climate Repair in Cambridge, Dr. Shaun Fitzgerald, about how buildings can be adapted for climate resilience and the potential for flipping them from carbon sources to carbon sinks. With many of the world's largest future cities yet to be built, and much of existing infrastructure in developed countries being unfit for extreme climate scenarios, it is essential that building development projects and innovation are able to meet and beat the challenges that lay ahead. Recent extreme climate catastrophes demonstrate that we need to start adapting to climate change right now and at scale. The theme of adaptation planning is one that I will be exploring more in the coming weeks. If you are listening on YouTube or GENN.cc or another podcast channel, please do post your thoughts on the content in the comments, and I will always read and try to reply. Your feedback is most appreciated. Please do subscribe to Shaping the Future at GENN.cc, where you can also see the whole podcast archive, as well as interviews, panels and articles from the last 5 COPs as we head towards COP26 Glasgow. And if you want to support my work, please do so via the Patreon links on GENN.cc. I'll be covering COP26 with filmed interviews and lots of additional content throughout the 2 weeks. Thank you for listening. Shaun, can we start by discussing, with relative to net zero goals, where are we currently with buildings emissions, whether it be from existing or retrofitting or planning new builds at the moment?
Buildings are a real challenge for society. So globally, they are responsible for something like 30% of all energy use. Now, some of that energy is going to be provided by electricity that's come from wind turbines and therefore doesn't have any emissions associated with it. But the lion's share of it, I'm afraid, the electricity is not coming from renewable sources. And then more importantly, in areas where you have heating provision, much of that heating is coming from gas. So we've got a lot of problems with buildings, new and existing, but even the new ones are already built with the infrastructure that they're going to be emitters for some time in the future.
And given the population challenges, it's going to require colossal building infrastructure projects worldwide, retrofitting for resilience. I mean, if you look at all the impacts we've seen just in the recent weeks, can these emissions be reduced to zero or even better?
I believe that these emissions absolutely can get to zero in buildings. The answer first is that we need to try and reduce the energy use per person per square meter of a building, and that just means making our buildings more energy efficient in the first place. So things like improving the insulation levels, which will therefore reduce in winter the heating bills. Actually, in summer, if you're air conditioning a building, it will even reduce the air conditioning loads because you're shielding the interior from the external solar gain and the hot temperatures. So making our buildings more efficient is the first objective. The second one, and this is important, and it's particularly pertinent for existing buildings, is where whatever energy is being used by the building is electricity, ideally, not gas, for example, for heating. Because if gas is your vector for providing a source of heat for the building, which you then ignite, you then got emissions arising from that building. If you've got electricity, which you're, for example, then using it to drive a heat pump, which can use external air as your heat source, so you're mining cold air and you're stealing heat from that. That's the way this wonderful technology works. Then what's doing the work is electricity, and you have a choice by wider society as to where that electricity comes from. And if it's from a renewable source, we've then got an emissions-free building. So those are the 2 steps: make it more energy efficient in the first place, and then go and make sure that you're using electricity as your vector. And making buildings resilient, we'll come on to that perhaps in a few moments' time, but what do we need to provide occupants by enhanced air quality, enhanced comfort conditions as society progresses?
So on top of all of the net zero sort of benefits and this kind of stuff, are you saying that there is a benefit to the inhabitants in terms of creature comforts and that kind of stuff?
There is. I'm sure many of us have been in buildings which are, in the height of summer, stiflingly hot. I've lived in houses myself, even in England, where the summer conditions upstairs are just unbearable. And the ridiculous reason is that the solar gain from the day in the height of summer onto the dark roof tiles, then with inadequate levels of insulation in the attic, mean that you then have radiation at night from this hot attic into the bedrooms, and it's just unbearable. And if we put insulation into the attic, we would have ended up with a much cooler nighttime temperatures, because with the windows open, you're no longer in an oven. So better levels of insulation actually weirdly provide you with a cooler space in the summer, and they most definitely provide you with a warmer space in the winter, because any heat that you then put into the space doesn't just leak out through the fabric, but can actually be used to heat the interior air.
You mentioned England, where I imagine there's a hell of a lot of retrofitting to be done, as well as new builds. But then you go to other countries where cities are just starting to really grow. Are these solutions where the knowledge can be shared globally, and where this kind of boom, which we have to go through with our growing populations, etc., can be benefit worldwide?
So the building standards, new buildings, are much better than they were 30, 40 years ago, without a shadow of a doubt. And those building standards, if they are applied by the construction industry, so the community, including the designers, and importantly, including the contractors who build the buildings, and then ideally the people that go and check the buildings, the local authorities, as long as everyone's singing from the same hymn sheet and singing properly, you'll end up with actually buildings that work rather well. And in particular, you'll end up with buildings that, for example, keep the heat in the winter. And think about an office building where you're not there 24/7, or most offices are not. So they're there, people are there, I don't know, maybe 12 hours a day. Let's say actually we've got a work-life balance and it's 8 hours a day, so it's 1/3. You've got 2/3 of the time where it's relatively unoccupied. You've had all the heat being generated by the IT equipment, people themselves, maybe the lights, during the day, in a winter day. What you want to do is to make sure that the building then doesn't cool down at night, which then requires a whole bucket load of energy to preheat the building in the following morning. So as long as the building is well insulated and reasonably airtight, actually that building should almost run for free when it comes to heating, because of the heat that was from the previous day being used to make sure that the space is still reasonably warm at the beginning of the winter day. And then once people are in there, it can work pretty much for free, especially if you have a heat recovery system. So building standards today globally, if you were to be using the ones from the Western world, for example, there is a lot that can be done to reduce energy use and therefore carbon emissions associated with the built environment.
Okay, and are you suggesting that if regulations are used wisely and implemented, that they could form a kind of blueprint that can help this go much further and farther beyond?
So these are really big ifs, Nick, all right? Therein is the issue. If we even applied robustly, rigorously, the standards that we already have, we would make huge strides in terms of the energy use and therefore the emissions associated with the built environment. It's because, certainly in the UK, the construction industry, has got some challenges, and they were laid bare with the very, very tragic Grenfell Tower incident. And the report by Dame Judith Hackett clearly focused on high-rise buildings, but it revealed some really challenges within the industry, and it's to do with being very fragmented. So lots of pieces, what we call in the value chain, and wherever you have handover, between a customer and a supplier, and we call it the battle of the forms, the T's and C's, terms and conditions. And just every time that happens, who's doing the checking? Which is why you then have this, in Grenfell's case, was to do with cladding on the outside of the building. And well, was the cladding itself the problem? Was it the way that it was installed? And what did the regulations say? What needs to happen is that the building industry needs to be sort of overhauled. So the standards are one thing, it's applying those is another. And that's the real issue that we've got with the construction industry. To really make great strides, it's about improving the way of working within the industry. And I think that's possibly a lesson learned from the UK that can be shared more widely as well, because it'd be unlikely that those problems are germane just to the UK. I would suggest that these sorts of problems exist elsewhere in the world as well.
Sure. So, Shaun, we've talked about reducing emissions. Can buildings go further into negative emission territory?
Well, Quite possibly, yes. And this is about thinking differently about actually what we're doing with buildings. We have a problem that just getting to net zero emissions is not going to be sufficient. We need to go harder than that. We need to actually take greenhouse gases out of the atmosphere. We've got to undo the damage that we have been inflicting on the climate for the last 100 or so years since the Industrial Revolution. And there are some technologies being developed right now that could possibly be applied to buildings. And one of those is looking at the oxidation of methane in the atmosphere. So methane itself is a fairly low concentration greenhouse gas, 1.7, 1.8 parts per million. If you compare that with carbon dioxide at 415, at first glance, you think, well, let's focus on the higher concentration gas. The problem is that methane has got a much higher, what we call global warming potential. It's got a shorter lived presence within the atmosphere, so it decays rather more quickly than carbon dioxide in 12 years or something like that. But instantaneously, it's got 120, 140 times the warming effect of carbon dioxide. So all round, it's probably another quarter of the greenhouse gas effect is actually as a result of this, just under 2% of methane emissions. How do we get rid of methane at such low concentrations? There are technologies being developed right now called photocatalytic converters, where the job is to try and convert the methane into carbon dioxide. So why from one greenhouse gas to another? Well, it's because it's far less potent. It will then last a lot longer, of course, in the atmosphere as carbon dioxide, but that's what it's going to get oxidized to naturally anyway. I just want to accelerate the oxidation so that we can get this stuff out of the atmosphere. And photocatalytic oxidation of methane is well known, but it's still being developed really to figure out what the costs are and how on earth you can get enough of the atmospheric air passing over materials with a catalyst, this photocatalytic substrate, which can be something like zinc oxide or titanium dioxide. The idea is that, well, what are we already doing in society that's got lots of surface area? Not just buildings, but the infrastructure, roads and things like this. Just the amount of infrastructure that we are building is huge. And every surface, therefore, has got the potential for air to move across it naturally as a result of the wind and buoyancy flows. So the role of the built environment as a potential way of coating the materials for getting rid of our methane is extremely exciting. It's still at the research stage because we've got to get the costs of the material down sufficiently to then make it worthwhile for relatively small amounts of air passing over any given square meter. But we've got so many square meters of the built environment, I think it's worth exploring.
Given the scale of the methane emissions we're talking about, and they seem to be increasing quite worryingly, you need something that is a sort of counterbalance to that scale. So this could be really interesting. So overall, is this a step towards making human habitats a more integrated part of the biosphere in terms of managing greenhouse gases?
Well, I think we do need to think differently about our built environment going forwards. And it's not just about climate change. Climate change is clearly the biggest existential threat that we're facing right now. But the way to go and tackle that is to integrate it with other challenges that we've got. For example, our well-being, just here and now, because how can I get people to maybe spend a bit more money on doing something with their built environment today, when the real beneficiaries of that money are going to be the next generation? And I mean, not just people, but life itself in all forms. So the way to think about this is to look at the benefits for changing our built environment. And for example, the use of more plants and things like that within our built environment provides a cooling effect here and now. So if you have shadier regions and they're natural, therefore actually if they're deciduous, the leaves won't be present and you get more solar gain in the winter when you might need it in the northern hemisphere or away from the tropical regions. And yet in the summer, when they're leafed up, they provide a natural shade. They can also provide a sort of a buffer with the moisture, so they'll actually provide evaporative cooling as a result of the green effect. Moisture is an amazing air conditioner, and it's just as a result of rainfall. So the way that we design our cities with a lot more green space, and I don't just mean having parks, I mean green space even within the streetscapes, different ways of thinking about how we might make our cities more in harmony with actually what was there before, which was a more natural environment. And those are the sorts of exciting developments I would like to see really being pursued, where we can bring climate change, reducing our energy emissions, energy use, reducing carbon emissions, providing benefits here and now to society.
And how does all of this integrate with your work with the Centre for Climate Repair?
Well, the Centre for Climate Repair has got three technical objectives, and they are firstly, to reduce emissions, and the work in the built environment is first and foremost about reducing the emissions associated with that. The second one is to remove greenhouse gases, so hence the comment regarding the potential for things like methane oxidation. The third one is to repair the climate. So looking at particularly damaged climate zones, and that's such as the polar regions, the Himalayas. You know, when glaciers go, these are irreversible, certainly on timescales that we care about. We've got to try and look at ways of either preserving or even repairing those glaciers. And that might mean looking at radiation management, solar radiation management in some form, whilst we get our house in order on the reduce and the remove bit, because those are the things that really, really matter. And I would say that the targeted interventions, the repair bit, is sticking plaster. It's probably many decades, if it ever gets deployed, that we might need that sticking plaster, but it's not the answer to the climate problem. The answer to the climate problem are the first two. And our fourth objective is actually looking at not just the science, but looking at the policies that are sort of going to be necessary globally, the agreements as to go and get everybody working together on all of these three technical objectives.
Oh, brilliant. Well, thank you very much for speaking to me. It's been fantastic to get some insight into what you're up to.
Thanks, Nick.
Thanks again for listening. If you are interested to help support this series and help expand the discussion around climate topics, then please do consider backing my channel via Patreon. It will help me produce more content, and you will also gain access to more expert interviews. It would be great to engage more with audiences too and understand your views on these topics.